All right, guys, in this portion of the video, many of you already know that I've just got done moving. I'm now living in Tennessee. That's where my company will be based. And I just started working with a new corporate client. I get lots of questions on my resume, and it's expanding greatly. And I want to start doing videos showing the expansion because I feel, as my father once said, people really will judge you based on the people you surround yourself with. So you can see this email here from an enclosure that I was working with the design engineer, Singeth, at a company called Hesperos. You can see here that it is confirmed. Hi, Vince, the payment should be made now. Yes, thank you. I received it. I'll keep you informed on the progress. He just became a corporate client of mine, and I want to give you the background on just who this gentleman is. If you come over here, you can see I just did a Google search on his name. Many of you can do that. Okay. We can see here that he's Department of Mechanical and Aerospace Engineering. He does carry a PhD. And once again, as we come in here to LinkedIn, he worked for a company called Micronics. And what's interesting, if we look here, University of Central Florida College of Engineering, Computer Science, he's got a doctorate in philosophy and mechanical engineering. If we go over then to the company in which he's employed now, it's Hesperos. And they're known as the original human on a chip company. And this I find fascinating because I love technology like many of you. And what they're working on is transpiring any manual position into robotics dealing with samples with human tissue. So he's actually doing robotics based around more or less rare diseases they're doing research with. And you can see exactly what this website entails. Okay, once again, they are based in Orlando, Florida, but this shows you, I think, and gives you a feel for just who I'm working with. And in order for you to understand where my prices are, what I try to do with my clients, I think that shows when people of this caliber contact me, these are the people that understand it. These are the people that say we don't have a choice in making a wrong decision. We want to get with somebody who does this as a professional and will get us the results we're looking for. And that's how we ended up designing his enclosure. He saw my videos. He made a determination at that point. And once again, knowing his educational background, I'm sure he doesn't do things lightly. We spoke on the phone. We did a consultation, and we get the ball rolling and things start happening. So as I get the enclosure in for his company, I'll show you the design because I know many of you want to see that kind of stuff. And in this way, you'll get a better feel, once again, of the expansion process with the company. Because again, it's very, very neat to think this will be the future. There will be integration with AI and human tissues. I think this will definitely be what we'll be seeing within the next 5 to 10 years. We're seeing an explosion all over the place. Many of you already realize that. But again, to see that level of somebody who once again is defined with the background he has and making the choices he's made, I hope that you guys then understand what I'm telling you to be accurate, because this individual would not make a mistake in choosing someone just based on, hey, that design looks neat. And that's what so many end users unfortunately do. They look at price and then they decide, hey, this looks neat and I want to work with that company. And they really have no idea of who they're working with. Hey guys, it's Vince. Today we are up to volume number 23 of CNC controllers built incorrectly. Now, if you're new here or you've just subscribed, I highly recommend you go back into the early volumes in my series so that you can recognize the pattern that many of these YouTube content creators follow when building CNC controllers and filming it. Now, there's a huge issue with this because, of course, social media doesn't really do any vetting. And unfortunately, many of you who, once again, subscribe to them or are looking for real information on how to work with a CNC controller in terms of assembling it and understanding all of the know-how that needs to go into that as far as all the details, you guys unfortunately suffer. That is why I started this series. And honestly, if you're wondering why CNC Zone and many other sites like it have so many posts with so many different issues of guys having virtually the same issues, you stay tuned to this channel and I promise you'll start seeing exactly why. Let's jump right in. We've got a new compilation today.
At the CNC, and the goal today obviously is to get the electronics installed and all wired up. I've pretty much decided this is how I'm going to lay.
So when I'm discussing the patterns in the previous videos, I want you guys to pay close attention to the breakout board this content creator is using. Not only is it USB, standing for Universal Serial Bus, and you guys know or should know from previous videos in the series that Universal Serial Bus is not to be used with CNC robotics because it's unstable. Once again, I will put the excerpt here on the screen from Balzis, lead engineer at CNC Drive, who manufactures the UC100, where they discuss what they found with the UC100 as far as it disconnecting from people's computers sending signals, and that's why so many of you have issues with this. Now, not only is his board USB, but it's the exact model other content creators in this series have used. I would say at least 5 other videos in this series are using the same breakout board.
Everything out. You can see I've made a few changes here, which I'll explain in a second, but I've got my 3 fuses in here now. I've got the 10 amp and the 2 separate 3 amp fuses. 10 amp will power the spindle. One of the 3 amps will power the control electronics, including the 2 power supplies here, the NEMA drivers, and these sort of boards, and then the other 3 amp fuse is dedicated just for this Intel NUC.
So now we get to discuss a topic seldom seen, but this one is very interesting. Usually we see content creators want to install VFDs mounted in their electronics enclosure with their drive components and everything else supporting the CNC controller. Now, of course, that's a bad idea because of the amount of EMI that the VFD releases. Again, it's the largest amount of EMI because it's powering your spindle, which draws the largest amount of amps, therefore the highest amount of energy creates the largest amount of EMI. Now, we've already discussed just a second ago what USB is dealing with by itself, Universal Serial Bus, and why it's not optimal for production CNC robotics, in the fact that it's extremely sensitive to grounding, voltage spikes, PC problems. I mean, it goes on and on and on. So now with the release of miniature PCs, this content creator thinks it's a great idea to install this in with all of the other sensitive electronics. Because, of course, in his mind, he's thinking he's making things neat and confined, and it's just going to be a real nice unit. Unfortunately, when it comes to engineering, guys, it's not always about making things neat if it's counterintuitive of you providing yourself a stable production robot. And the only way you would know that is to have the experience. And this individual doesn't. And it's shown by looking at this, and anyone would think, well, if my breakout board is sensitive to EMI and is sensitive to voltage spikes and grounding, what do you think is going to happen with a miniature PC confined in an electronics enclosure? It's the exact same thing. And this is why I tell you guys, you've got to pay attention to details. It's interesting that the content creator is even going through, and this we've seen in previous videos, they like to lay out all the components. Hey guys, here's what I'm working with. And then they go from there. It's up to you guys to do your due diligence and spot the knot. Making things neat only matters if you still are able to produce a production robot that is going to be stable. It doesn't matter what size engine you install in a car if the transmission doesn't support the extra horsepower. So we see the content creator has begun mounting his electronics to the back of the plywood he plans on installing in his electronics enclosure. Guys, I have said this in previous videos, if you use anything that's flammable within your electronics enclosure in the US, I believe he's in the European Union, regardless, their policies are virtually the same, your insurance company for your home or your business will not cover you for any damage done, and God forbid if you hurt someone. I'm sure you wouldn't forgive yourself. I know I wouldn't. There is no excuse for this behavior other than the fact all he cares about is getting clicks and views.
Right guys, so there it is. I've installed all the hardware onto the board here. As I said, I've left plenty of room for running some cables to mount the switches on the side here, and I've now secured the boards down as well. And I think I've maximised the control box as much as I can. I've spread everything out. One thing worth noting as well, a couple of people may be concerned that the power supply has a fan on the back here. As you can see down there, that is generally an outtake. However, I've opened the power supply up and turned that fan around so the air is an intake, and then it'll come out at the top here. Now the reason I've done that is because in my control box I'm going to have two intake fans at the bottom of the enclosure, and I wouldn't want that to be essentially throwing air out towards a fan that's drawing air in.
So instead of just rethinking what you're putting in your electronics enclosure, and instead of really thinking about the warranty situation from your vendor of your power supply, it's better to just open up the power supply, change a fan that's an exhaust fan, not an outtake fan. And the reason it's an exhaust fan is because the manufacturer understands that power supplies, when they have their enclosure on it, has a condensed heat. And they realize that power supplies are designed to support other electronics mounted within an electronics enclosure. That's why they're mounted in an exhaust format to be evacuated by the electronics enclosure's cooling fans. Now, what this content creator doesn't understand about details, just because you mount cooling fans in an electronics enclosure doesn't mean they're strong enough, unless you understand CFM ratings, so that you can evacuate enough heat to keep the system stable. I hear this done all the time by content creators trying to act as if they're covering every base. And what they forget to realize is, just because you buy a computer fan doesn't mean you understand the CFM rating of the cooling fan. I've had so many guys tell me, man, your system is loud. My system is loud because it's not designed to be a PC. It's designed to be an industrial piece of electronics that, when put in an industrial environment, stays cool. These guys think that you just select any fan off the shelf, mount it, and you're good. This guy has right now, between the VFD, and I can't see what size VFD that is, but let's say it's between 1.5 kilowatt all the way up to 2.2 kilowatt, just so everybody's on the same page. That's 1,500 watts of energy up to 2,200 watts of energy by itself. That doesn't include the power supplies, that doesn't include the drives. When you factor in all of that heat, he would need massive cooling to keep that enclosure properly cool. By far more than most of these guys understand with their cooling fans. And we haven't gotten to that part yet, but we'll get to see what he selected, if he even covers that detail, because it's very, very critical. A lot of guys miss it, and we'll see exactly where this is going.
So ideally, this will get cool air sent straight through it, which is ideal. And that will then vent out the top here. I'm going to have vent holes at the top of the control box so that hot air will naturally rise up out of the control box.
I really enjoy when the content creator acts as if he has it all figured out. He's just explained to us that hot air rises. That's true. What's really interesting, though, is what he's just explained, is that he's mounted a cooling fan for intake on the bottom of his enclosure. Well, he also has his VFD and two power supplies mounted there. These are the components that generate the most heat in the system. So when that intake fan is blowing that air through those components, it's essentially heating that air much hotter and blowing all of that hot air right over his drives and right over his breakout board. Now, that makes no logistical sense in any engineering format, and all he had to do, if he really was uncertain, was do a Google search, or better yet, if he had any familiarity with a modern day PC, open up a PC case. 98% of them have the power supply mounted at the top of the enclosure. Why? Because the manufacturers understand that the power supplies generate the most heat, and you want to get that heat out as fast as possible, because if it was mounted at the bottom of the enclosure, for the most part, without the proper evacuation fans sucking out that heat, you're blowing it essentially over your processor. That would make no sense. Your drives in your system generate much less heat than the components he has there powering them. So it makes no sense to mount them at the bottom. It would have made more sense to mount your drives at the bottom where they generate less heat, and therefore whatever cooling fans he selected, which of course once again will have to be determined if correct with the CFM rating they have, which I'm sure he's not going to cover, would actually have to be strong enough to once again blow through those devices, meaning his drives, and then go up to his evacuation cooling ducts at the top to evacuate heat from the system. Now, this is why I always recommend 2 fans in a system that's using an IDS format, individual drive system, henceforth IDS. The reason I say that is you have a cyclonic action, meaning one fan is intake, one fan is exhaust. So basically cool air is coming in, hot air is going out. They're working in conjunction together to give you a symmetrical cooling effect.
Right, so I'm at the control box here, and I'm going to try and show you as much as I can of this installation process. Like I said, I bought 2 80mm fans, which happen to fit very nicely on the sides here of the enclosure. So I think that would be a nice entry point for some air to draw up from the bottom. Now what I'm going to do in this case is drill out some holes. Then I'm going to add a dust filter and place the fan on top, because you really want to keep dust out of this.
Okay guys, so we see this in a lot of content creator videos. They assume all they have to do is install some type of cooling because it fits. And when I say that, of course, I'm talking about cooling fans. He selected an 80mm cooling fan. Well, if we look into Google, on the average CFM output of an 80mm cooling fan, you can see what we're outputting. And what's really interesting is, even on a high-end 80mm cooling fan, you're looking at about 100 CFM of airflow. With the amount of componentry that he has in there, and then on top of that, he's never disclosed the size of the enclosure he's working with, but in order to cool the amount of components he has in there, you're looking easily at 250 to 280 CFM on average. Now, of course, that number is not going to ever be exact. There's no way it will ever be exact, but you need at least that amount of airflow, especially to move and pressurize that enclosure, to pressurize it enough to where that hot air is going to escape through the vents. Now, what we know for sure is that he selected fans based essentially on either what he had or the fact that they were cheap to price. And that's exactly what these content creators do. They never cover the details of what actually has to be done because they don't know what has to be done. They go to Home Depot, they pick up spackle, they watch a DIY video on YouTube, and now all of a sudden they're drywall guys. Next week they'll work on painting, and now they're painting guys. This is not a DIY skill set for most end users. This is engineering, and I've said this before, takes explicit amount of details to get right. Now, are we certain that he's going to have a failure in the sense that the system will be unstable simply by overheating? We're not. But you can rest assured, how many of these variables, and think about this, need to be built into the system incorrectly to affect it? That's what I really want you to think about. When you keep seeing all of these half measures being taken just to apply what he calculates or what he figured will be adequate for the system in terms of either cooling or wiring or whatever it may be, how many of these variables do you need to get wrong in order to destabilize a CNC robot? And I can tell you for a fact, it only takes one. One is all it needs to get wrong. Now think of all the variables that go into building the robot, and you see why so many people are on CNC Zone and other forums posting problems.
So, as you can see, I made the board as big as it can possibly be, but it's not going to go in just straight back like that. So what I've done is I've done it so that I can sort of hook it in. You get that side in first. Then we can pop this around. and you can see it literally just falls straight on. I'm not going to let that go obviously there because it'll fall forward, but you can see that fits in there nicely. I think it looks pretty good. I might actually just try and get one bolt on if I can find it. Bear with me. There we go, so that's in there. So you can see how easily I was able to just pop that.
It's interesting to point out that even though he installed the cooling fans, neither of these cooling fans are blowing over the VFD, which of course will generate the most heat in the unit due to the amount of amps it's drawing to support the spindle.
So it's a lot safer. But that's basically where I am with the enclosure at the moment. All the holes are drilled, it's ready to be installed now. You can see the fan mount on the bottom there. And now it's just simply a case of installing that.
Alright guys, so we can see here where he's mounted his fans in the enclosure. You can see that we have 5 holes drilled for the fans to allow cooling air to pass through. Now, logically, the best way to mount a fan for proper airflow, so we do not have a restriction, would be to use the proper sized hole saw. This is completely inadequate because he's smothering the fan by once again only giving him a percentage of airflow due to the fact that the air volume is going to be restricted because he still has material there present from the enclosure in front of the fan. Now factor that detail in once again with him using a filter suffocating those fans even more, and you have a recipe for disaster. And I'm telling you right now, these are the details that these content creators never discuss. They go over things really quick. They're hoping that the content just gets longer and longer and longer and you just stay tuned, instead of guys in their comments section pointing these details out, because this is critical. And just to make it in a more basic analogy, if you think of a PC case, and I've said this before, you'll never find mounts for fans done like that. I mean, they're always in a hole format. Now, they will use usually a filter if it's a high quality case, but they're always done in a full symmetrical hole format so that the fan's airflow is not restricted. This is critical, and once again, why you got to be careful.
So I've cleaned up all the holes that were in the enclosure here, got rid of all the burrs. I've also added my switches on the side, so I've got my emergency stop down the bottom here, and I've got my 2 switches for the 2 different circuits I'm going to have. I've installed the vent at the top. I've got dust filters between the enclosure and the vent, and also the fans and the enclosure.
So what he's just described to his audience as well as us is that he's installed a fan filter at the top of the enclosure as well to prevent dust from actually getting in the unit. Now that makes sense. The unfortunate side is that his lack of knowledge in doing that defines that, once again, we're restricting airflow leaving the case now, because that same filter that he's installed on the bottom works in conjunction in the opposite format when you install at the top. It's still restricting airflow, and that's why selecting the proper size fans with the proper CFM rating is essential. That's also why drilling out and machining your enclosure to the proper size hole is essential, and that's also why I recommend using cyclonic cooling fans, one pulling air in, one extracting hot air out, to make sure you do not have stagnant air, which is just basically heated air, circulating around your components. This, once again, is a true recipe for disaster just in the heating factor, and we haven't even discussed ambient temperature air where he's working. But I'm telling you guys, these are the details that are most overlooked, and you never see this kind of stuff usually discussed inside of the forums. You'll hear them talk about everything. They never discuss cooling, but this is really interesting because you get to see it done now firsthand by the content creator.
And then these wires are going to go to wherever they need to go on the drivers, and also for the sensors as well. I think this one is a 4-pin, so that's the motor connection. Again, everything is shielded just to play it safe.
So he explains everything is shielded just to play it safe. Well, as we look at this controller now starting to take shape as far as his wiring, you guys should be paying attention to the fact that we are going to be looking as we progress through this, and I'm trying to finish this up because this is a pretty long build video, in that we're going to be looking for a ground bus allocated for his shield drains on this shielded cable. Let's see if we find it.
So here we are with the final update on this enclosure for this video, and this is where we've got to at the moment. Extremely happy with it so far. I've still got to tidy up a few cables and sort of zip tie them together so they're nice and safe, but I've achieved my goal for the end of this video, which is to have everything wired up, have all the connectors in and the switches, and be able to turn it on and have everything function correctly.
Okay guys, so we know that his imaging was kind of fuzzy from his camera on his finished overview of his system. That made me search his channel because I realized many content creators always like to do a part 2 follow-up. He just so happened to do that. Well, after finding that, you can see down here, I'm actually inside of his video of part 2, and there's the VFD programming stage, and he actually gives you a very clear image of the finished system. Now, the software I'm using right here is a very powerful tool from Topaz. It's called Photo AI, and it basically takes a still image and upscales it using the latest AI technology, similar to what we use with robotics. It's doing with a software version of it. So what I'm going to do is take away the preview photo and go to the after. And what I'm going to do now is just come over here. And now you'll notice as we zoom in, I can go in and just zoom as close as we need, and you can see exactly what's going on here. We even see more mistakes than I pointed out. We see daisy chaining being done in between the drives, but right here we see shield drains, and it looks like this one is being daisy chained as well, or connected somewhere or not connected. Either way, as we come down to the ground bus, which is right here, we notice they're not connected to it at all, yielding his shielding on his cable completely ineffective. And this is something that many of these content creators do. They like to discuss using shielded cable when in fact the shielding on the cable is only effective if the ground drains of the cable are properly allocated to a ground bus to dissipate EMI. If they are not, you're essentially using standard cable, yielding them completely ineffective for EMI mitigation. Now, looking at this, once again, we're hoping that ground bus is not just mounted to his trusty wooden board here and mounted to the back of the metal electrical enclosure so it can dissipate ground to whatever's attached to it. Again, this is a really clear look at what not to do. We also see a cable here being used. I can tell you right now that is not double shielded, and it's a fact because of the actual width of the cable. Double shielded cable, guys, is very distinct. And if we look at the other diameters of cables being used here, he used a larger diameter cable. However, this is not double shielded. On top of the fact, we see the trusty content creator electrical tape. Electrical tape has no business whatsoever within a CNC electronics enclosure. We also notice that over here on his shielded cable that he's using for his drives, none of these ends are finished. And when I say finished, they should be insulated. You should never have shielding or anything conductive sticking out of these cables. This is not only best practice for safety, but we don't want to short out any potential electronics if there is grounds connected to these shield drains, as they should be, and that you would actually short something out because it makes conduction to another conductor or possibly makes contact inside one of those terminal blocks within the drive. This should be purely logical. But as we source this system again and just come back, we can review now that we've got, of course, the VFD right here. Then we have the stepper motor power supply right here. And we also have a breakout board power supply. But when we come up, and I want to draw your attention to this, this is why I love this software. I can keep zooming in, and you can see this box right here. Many of you are going, man, what is that box? That's an additional power supply to power his miniature PC. So I want you to think, and we've just talked about all of the issues with EMI, and I want you to think you have a VFD, once again, a stepper motor power supply, breakout board power supply, and now the fourth miniature PC power supply, all surrounding very sensitive electronics that require 5 volts pulse to actually dictate how those motors turn in direction and when to move. Now you understand why there are so many posts on CNC Zone with problems because guys overlook this level of detail. You can see it in every system I'm showing you. These are the types of patterns these guys follow. They look at content. They think the system is done just like he stated when basically they turn on the system, the components turn on, everything appears to function as it should. That is not a stable system. All that is a power test. A power test means nothing. The only way a robot is considered stable is when it's tested in a real-world environment doing what it's meant to do, which is producing product or recreational widgets. Whichever way you want to call it, I don't know anyone doing recreational widgets. Everybody I know on my channel typically is developing products to resell, and that means that until that robot is able to do that in a stable platform and what it's directly designed to operate as, it is nothing. This is a giant paperweight.
So here's a quick video of a homemade CNC conversion for a Bridgeport model BRJ mill.
Hey, you heard it guys, the introduction. We're dealing with a Bridgeport, which is an amazing system when they're converted correctly. Let's see where this goes.
Those stepper motors are controlled by micro step drivers, which are in the little box here.
Okay, so the content creator is showing you his electrical enclosure with his retrofit, and we really can't see this. Let's use this snapshot once again in Topaz Photo AI to show exactly what's going on here. All right, guys, let's delve in and see exactly what we're working with here. You can see that this is a snapshot from his video. If you look over here, it says Arduino. And then over here, we could see the enclosure, and of course it's very dark lighting. Once again, I'm using Topaz's Photo AI. I'm going to click on Add Enhancement, and we're going to go over here to Adjust Lighting, click on it, and it's enhancing right now. You can see that right over here. There's the preview, and everything has been corrected. Now I'm just going to close that out so we can see, and once again, we can see exactly what's going on. I'm going to zoom in, and as I do that, it's going to readjust. And you can see that we have the trusty daisy chain going on. This doesn't even justify a real electronics enclosure for CNC controls. We see the Arduino USB controller being used, which once again has no place for being used within a CNC. I'll post on the screen again Balzas's email. It's in virtually every one of my CNC fail videos now. You guys can check it out for yourself. I want to keep this ending of the video as short as possible, but it's really a disgrace when we see content creators really just butchering a robot like a Bridgeport mill, because these mills are designed for industrial machining, and when they're retrofitted correctly, they are amazing. I have a lot of clients making a lot of money with Bridgeports that are retrofitted. This virtually assures you have problems, and I cannot emphasize that enough. If we look at this and we zoom in, we'll let the software recalibrate, and you can see basically everything here being done incorrectly. From daisy chaining on both ends, I don't even see any cooling here being done. It's just a mess. Nothing is shielded. You can see those cables are bare. I mean, it's basically every problem that I've just discussed in the previous segment, you guys can now see once again for yourselves right here on a full-scale Bridgeport. So when guys say to me, is this just on routers? Is it just on plasmas? That's all you've covered. Now you've seen a Bridgeport. And we'll go through the rest of the video and we'll see what he's done as well.
A Raspberry Pi, which is just on the wall at the back there. There you go, Raspberry Pi.
Content creators explaining he has a Raspberry Pi, and we can see the VFD right there, guys. Once again, summing up just how dangerous these guys are when it comes to dispersing information. They are fine making their own system any way they want. Please don't misconstrue what these videos are trying to convey. If, however, you're filming it and you're trying to disperse it to the masses in order to get views on your channel, that is showing that you are trying or motivating yourself to become an authority. You should not be showing these videos, as they are not best practice. It will sabotage those that want to learn how to do things correctly. All right, guys, that wraps up volume number 23. And once again, I want to thank you all for your support. I will keep the videos once again coming as long as you're interested. And from the feedback I'm getting, you all are very interested. Once again, I hope that you've witnessed some more patterns that you can follow from previous videos. I've said this before and I'll say it again. Content creators are performing entertainment. That's it. Do not take entertainment as education, or you will possibly be burned, and many times you will. I'm telling you that if you're serious about getting into production CNC robotics at any capacity, whether you want to call it a hobby, whether you want to call it recreation, whether you want to do it for business, hire the correct professional based on fact, based on their education, based on their proof. That is where the due diligence comes in. Take your time and invest your money and time correctly, and I'm sure you'll be happy with the result. Take care.